Welcome to the deep dive. Have you ever found yourself wondering what true intelligence in AI might actually look like? Not just AI that performs tasks, but AI that genuinely understands and maybe can even explain its own actions. Today, we're taking a deep dive into a really interesting concept called Sophimatics. We're looking particularly at insights from Gerardo Iovine and Giovanni Iovani's work on it. Our mission really is to unpack this new paradigm, to get to grips with how it aims to build AI systems that can, well, truly interpret context, grasp meaning, and even give reasons for what they do, moving us, hopefully, closer to a more human-like intelligence.
Yeah, and this deep dive, it really challenges a lot of our current thinking about AI, doesn't it? We'll explore how Sophimatics tries to move beyond just, statistical pattern spotting to something much more profound, a deeper cognitive function.
Okay, let's unpack this then. Our sources kick things off by saying, look, to really understand AI, you can't just look at what it does. You have to look at how it does it, especially when we're talking about intentional acts like making references or figuring out truth conditions. What's the fundamental problem Sophimatics is trying to get at here?
Well, what's fascinating is this split that some of the research highlights. There's a key difference. On one side, you've got what's called object-related intentionality. That's basically how logic symbols get their meaning, their reference, in a specific context. That part apparently is computable. We can figure that out. But then there's the other side, the self-related aspect of intentionality. Think of it like self-consciousness. And that seems to fall outside what science can currently calculate or compute. This distinction really highlights why AI needs to do more than just mimic behavior. It needs to actually perform and crucially calculate the reasons behind its actions.
Okay, so incorporating this idea of intentionality, what does that actually mean for how Sophimatics approaches building AI?
Well, if you connect it to the bigger picture by making intentionality a core logical and computational principle, Sophimatics is really aiming for a paradigm shift, a shift towards genuinely intelligent behaviors. Some researchers point out that complex things like making judgments that depend on context or applying truth values, well, you just can't explain those with simple statistical pattern matching. It doesn't work. So Sophimatics brings in more advanced logical and semantic processes to get past that limitation. This allows for much more flexible, sophisticated, intentional behaviors. It's a huge leap from, say, classical AI models, which are often just locked into fixed statistical links. And a key insight here is that meaning itself becomes relative. It's always shaped by the context, by the logical relations.
And this leads to AI that can interpret itself and others.
Yeah.
A bit like how humans do. That sounds, well, pretty ambitious.
It is ambitious, yeah. But that adaptive feature is absolutely crucial. As our sources suggest, structuring these intentional acts, it really calls for the use of appropriate logical and semantic methods. Think about it this way. This is essential if we want to build ethical AI systems, right? Systems that can interpret and apply ethical rules in situations that are always changing. They need to stay relevant to the context of the laws themselves. And building on that, let's think about how Sophimatics tackles aboutness, what something is about. This is really important. It makes a distinction between subjective intentionality, like how an AI's internal symbols refer to things out in the world, maybe recognizing a specific cat in a photo, and objective intentionality, which is more about how those internal symbols refer to each other within the AI's logical model, like how the concept cat relates to mammal or pet. This dual approach really brings aboutness center stage. It means the AI models are explicitly dealing with reason. And this enables something called intentionality inference, which is super important for things like AI collaborating with humans or explaining its actions or predicting behavior. Imagine, say, an AI chatbot. It could rephrase a question to make sure it understands which specific thing you're talking about. It dynamically updates its understanding based on the conversation. Our sources are pretty clear that these kinds of dynamic setups, they're just not possible in standard AI systems, which really underlines why Sophimatics is such a big deal. Now, true self-consciousness, that's still the final frontier, but what Sophimatics can do without that is still revolutionary for building intelligent, trustworthy systems.
Okay, we've talked about what this focus on intentionality, but the big question is how? How does Sophimatics actually achieve this deeper level of understanding and flexibility? Our sources really emphasize the importance of hybrid architectures. What exactly are those, and why are they so critical here?
Right, hybrid architectures, they're basically systems that cleverly combine different ways of computing. Early work in this area really pushed for bringing together different types of neural networks, distributed and localist ones with symbolic systems. This combined approach lets you build much more robust systems. And interestingly, it seems to mirror the kind of layered interactions we see in our own human intelligence.
Can you break that down a bit? What are the unique strengths that each of these components brings to the table in a hybrid system? Why is mixing them so effective?
Absolutely. Think of it like a team with specialists. You've got your distributed neural networks. They're brilliant at the initial grunt work, extracting features from raw sensory data, like pixels in an image. Then you have localist connectionist networks. They're better with more abstract stuff, mid-level data representations, recognizing broader concepts maybe. And then the symbolic architectures. These are absolutely vital for the high-level thinking, interpretation, context, and really importantly, ethical reasoning. The real magic happens when they work together. See, neural nets are great at feature extraction, even if the input is a bit noisy and distorted. But purely statistical methods, they just can't give you that higher order conceptual information, like understanding what fairness means. On the flip side, purely symbolic systems can be quite rigid. They lack the flexibility to deal with messy, real-world sensory input. So the research suggests that neither approach alone gives you both the depth for ethical reasoning and the flexibility for interpreting data. Hybrid frameworks just seem to be a better way of combining the strengths of both worlds.
So this approach helps AI tackle ambiguity. That's always been a major hurdle for standard AI, hasn't it?
Yes, exactly. That's a huge advantage. Standard AI really struggles with ambiguity. It's mostly based on statistical associations, and those aren't good at adapting when relationships or categories in the data shift around, which happens all the time in the real world. But by integrating symbolic and connectionist methods within a Sophimatics framework, the system can handle more complex operations. It can cope when the environment throws up fuzzy concepts, things that aren't easily classified, open textured concepts. This allows the system to shift gears, moving from just associating patterns, which is the connectionist part, to actual ethical assessment and reasoning using the symbolic part. It can handle high-level ambiguity in ways standard AI just can't replicate. And that's why this whole area is so relevant for designing the next generation of AI systems.
This all sounds incredibly powerful, very sophisticated. But how does this deeper understanding actually translate into practical AI? AI that we can, trust and work with in the real world?
That's where shared intentionality comes in. It becomes absolutely vital. Researchers focusing on this argue really strongly that intentionality needs to be explicitly modeled inside the AI as a logical property. And this isn't just some academic exercise. Doing this is what allows the AI to give direct, understandable explanations to us humans, which is, well, crucial if we're ever going to build real trust in these systems.
So current AI, even if it finds the best answer according to its calculations, it often can't tell you why it made that choice. It's sort of a black box.
Exactly that. It's often a black box. Our sources point out that most current AI techniques are just optimizing for a reward, which is usually just a number, a score. Now, this teaches the AI to pick actions that it predicts will maximize that score, but it completely misses the human idea of a shared intentional act. It doesn't understand the why in a way we do. So to bridge this gap, some researchers propose a clever form of inverse reinforcement learning. Essentially, it tries to model the AI's reasoning for pursuing a goal as its actual goal. It uses formal logic tools to kind of reverse engineer that why.
Okay, that sounds like AI that could genuinely operate within the same kind of sphere of understanding as a human. Not just interacting, but sort of understanding together.
That's a great way to put it. Yeah, operating in the same intentional sphere. By modeling the shared intentional act, the AI can act and communicate in a way that makes sense to us. Because we humans are, by default, intentional creatures, right? We have goals, preferences, a sense of self. This doesn't just lead to potentially smarter machines that we can understand and trust better. It's also critical for building more autonomous systems. Think about collaborative robots or self-driving cars. Our sources stress that it is imperative that the system understands and can explain the goal in mind. The problem with current AI often isn't that it fails to get the best score, but that it's simply unable to provide a reason for this. It can't explain itself.
And this transparency, this ability to explain, it must have really significant ethical implications too.
Oh, absolutely. Huge ethical implications. If AI makes decisions that affect us, but does it in ways that are mysterious or unpredictable, it could unintentionally cause serious harm. We wouldn't even know why. But by providing a rational, understandable explanation, AI systems built with intentionality inference. They offer a much better foundation for trust, for accountability, and for maintaining control. This is why intention and figuring out intention inference really needs to become a central focus. For practical AI research, yes, but also for setting AI ethical standards going forward. The research concludes that intentionality inference is an essential capability for enhancing accountability, for helping to build trust, and for enabling explanation in general. This is really where the core ideas of Sophimatics meet the practical needs of designing AI systems we can live with.
So it's about making the AI's, let's say, thought process transparent, even trying to reconstruct its intentions by looking at its behavior. That sounds like a really tricky but fascinating problem.
Yes, you've nailed it. It's about framing the problem almost in reverse. Instead of just predicting behavior from a goal, you're reconstructing a symbolic goal from the observed behavior. Essentially, equating figuring out intention with figuring out the goal. The whole point isn't just for the AI to predict an outcome correctly, it's for it to engage in understandable, contextual, intentional interaction, to actively try and figure out intentions together with humans. Our sources suggest this allows the system to model the goals that are implicit in human actions, and therefore predict future behavior more accurately too.
Wow, this really points towards a fundamental shift in how we even think about AI, doesn't it? Our sources mention dynamic and inactive cognitive systems as being almost the opposite of classical AI. Can you elaborate on this deeper philosophical foundation of Sophimatics?
Yeah, this is where things get really foundational, maybe even a bit philosophical. If you start with the idea that cognition is the embodied process through which an autonomous system negotiates meaning in relation to its environment, well, that raises big questions like where do categories come from? What are their roles? See, classical AI tends to use fixed static symbols. It processes them step by step. But dynamic cognitive systems, they rely on real-time interactions between different subsystems, and crucially, interaction with the environment to actually do cognitive acts. Researchers describe a dynamic system as having a different basic view of reality, an ontology that sees things not as fixed objects, but as ongoing processes and interactions. A system in this view can only exist by dynamically relating to its environment. And in this style of cognition, things like categories, relationships, even meaning itself, they aren't programmed in beforehand. They are generated. They emerge from the continuous back and forth between the system and its environment. Very inactive.
The meaning isn't fixed. It's constantly adapting, constantly emerging. That does sound deeply philosophical.
It is, yeah. It's a profound shift. You could say this kind of system treats cognition itself as the dynamic adaptation of categories rather than just manipulating fixed meanings. And this view actually has deep roots. You can trace it back to philosophers like Aristotle, whose idea of potential kind of resonates with this notion of adapting categories. Or maybe someone like Simondon, who talked about individuation being an ongoing process, suggesting that systems are always re-individuating themselves. Some sources summarize Simondon's idea quite strikingly. Quote, "To exist means to become, or rather, to become other than oneself, constantly changing." Now think about the implications for designing cognitive systems. They're huge. To learn a new category or a new interpretation, basically, to add new knowledge, or even just to modify an existing one, the system has to literally restructure itself, reorganize. And crucially, that restructuring can't be pre-programmed. It has to be an emergent process, something that arises naturally from the system's own dynamic operation. This is exactly the paradigm that lets Sophimatics systems adapt to new information, reconfigure themselves based on context and meaning, in ways that traditional static AI just fundamentally cannot. The ultimate aim. It's to build a computational system that shows truly emergent phenomena, emergent meaning, emergent intention, all through this constant dynamic interaction with its surroundings.
And this philosophical underpinning, this leads us straight to the idea of embodied AI, right?
Exactly. It connects directly. Other researchers really emphasize how intelligence emerges directly from the sensory-motor coupling, meaning intelligence can't be explained without referencing embodiment in the way that it allows the subject to act and perceive in their surroundings. It's about the body interacting with the world. So by designing dynamic systems with these tight perception action loops and coupling them with mechanisms for that contextual and intentional resonance we talked about, well, then you can develop AI that models intelligence much more like how we humans learn and act in an environment. The main goal here within this enactive theory is really to shift AI away from those classical disembodied computational models towards something much more embodied, adaptive, and interactive, a truly cognitive AI. Research concludes that by grounding intelligence in these sensory-motor interactions and highlighting the computational role the body plays, even a simulated one, these new paradigms overcome limitations of older theories. They move beyond just representation-based ideas and also beyond the view of cognition as just information processing locked inside the brain. In this view, real sense-making, understanding the world, comes directly from the body's dynamic dance with its environment.
So wrapping this up, what does this all mean for you, our listener? This deep dive into Sophimatics has really shown us a truly compelling vision for AI's future. One that moves far beyond just recognizing patterns, aiming for something profoundly more nuanced, more understandable, and maybe more human-like.
Yeah, we've explored how Sophimatics offers this powerful pathway. By integrating intentionality deep down, by using smart hybrid architectures, by focusing on shared understanding for transparency and trust, and by embracing this whole philosophy of dynamic, embodied cognition. It's a path towards AI that can genuinely interpret meaning, explain its reasoning, and even adapt its understanding as the world changes.
It's a vision where AI isn't just smart in a narrow sense, but also inherently understandable, truly trustworthy, and genuinely collaborative.
Which brings us to a final, maybe provocative question for you to think about. If AI can understand reasons and context in this much more human-like way, how might that fundamentally change how we interact with artificial intelligence, how we rely on it in our daily lives, and what entirely new possibilities might that unlock for all of us?
Something to mull over as you continue to explore the absolutely fascinating world of AI.